In this video, we will complete Activity 6C, Stoichiometry Practice, and we'll start with number 25 and go through till the end. So, looking at number 25, it says, when 5 grams of silver nitrate are reacting with barium chloride to produce silver chloride and barium nitrate, how many grams of silver chloride are produced? So as we went through the problem, I went ahead and I underlined our given value, unit, and substance, and then I circled what we are looking for, grams of silver chloride. So we're going to have to start by writing a balanced chemical equation, which is our hint right here. Start by writing and balancing the equation. So we first have silver nitrate reacting with barium chloride. So silver nitrate, so we have silver with a +1 charge, and nitrate, NO3, with a -1 charge. And then it's going to react with barium chloride, Ba, which has a +2 charge, and chloride, chlorine, which has a -1 charge. So it's important that when you're writing these equations, you keep in mind your crisscross method, so that you don't forget to cross down those charges to get the chemical formula. So always write them out. That's what I like to do. So when we get our crisscross, we get Ag1 and then 1 NO3 as well. So AgNO3 is one of our reactants, plus Ba with a 1, and then Cl2. So those are our two reactants, silver nitrate and barium chloride, are reacting together to produce silver chloride and barium nitrate. So silver has a +1 charge, and it's going to bond with chlorine, which has a -1 charge, so that will be AgCl. And then barium nitrate. Barium has a +2 charge, nitrate has a -1 charge, so we get Ba1. And then we are going to have 2 NO3s, so we put the NO3 in parentheses and put the 2 outside the parentheses. So here's our equation. Now we need to balance our equation. And what I sometimes like to do is I like to put lines in front of all of my reactants and products to remind myself to put a coefficient by each of them. So the first thing I notice is that the chlorine is out of balance. We have 2 chlorines on the reactant side and only 1 on the product side. So I'm going to fix that by putting a 2 in front of silver chloride. Then I notice that when I did that, I knocked silver out of balance. So I have 2 silvers over here on the product side and only 1 on the reactant side. So I'm going to put a 2 over here to fix that. And then I'm looking and I say, okay, I made 2 nitrates, 2 NO3s, so I need to check that. But I already have 2 NO3s on the product side, 1 barium, 1 barium. So now we're all balanced. I'm going to fill in some 1s. So that we can remember that we are completely balanced. We have a balanced chemical equation to work with. So now we need to start doing some stoichiometry. So our given value, unit, and substance, so 5.0 grams of silver nitrate, so AgNO3. And then we're going from grams of one thing to grams of another thing. So that's going to end up being 3 conversion factors. 1, 2, 3 conversion factors to get to our final answer. The first one is going to take grams of our first thing of silver nitrate, and we're going to convert it to moles. Then our second conversion factor is going to be our mole to mole conversion, so moles of AgNO3, and we're going to moles of our new substance, which is silver chloride, AgCl. And then our last conversion factor will have moles of AgCl on bottom, and we're converting back to grams, grams of silver chloride, grams of AgCl. So for our mole to mole conversion, all we need to do is look at our balanced equation. So we have 2 moles of silver chloride, so I'm going to put 2 moles of AgCl, and then I need to look at silver nitrate, and I have 2 moles of that as well. So 2 and 2 go there, and then to figure out how many grams are in 1 mole, we need to calculate the molar masses of silver nitrate, of AgNO3, and also the molar mass of AgCl. So we can get the mass of the individual elements by looking at our periodic table. So silver is 107.868, nitrogen is 14.007, so we can just round that to 14. And then oxygen is a 15.999, which we can round to 16, but there are 3 oxygens, so I need to multiply that by 3. Silver, we said, is 107.868, and chlorine is 35.453. So we're adding all these up using our calculator, so let's do 107.868 plus 14 plus 16 times 3, which gets us 169.868. 169.868 grams per mole for silver nitrate, and then we need to do 107.868 plus 35.453, which gives us 143.321 grams per mole for silver chloride. So now we just need to fill in these values. So for silver nitrate, 1 mole of silver nitrate is going to be 169.868 grams, and then 1 mole of silver chloride is going to be 143.321 grams of silver chloride. So now let's cancel some units out and do our calculation. Grams silver nitrate cancels, moles of silver nitrate cancels, moles of silver chloride cancels, and we can also cancel out these 2's because we have 1 on top, 1 on bottom, so those cancel out as well. So now we just need to type into our calculator 5 times 143.321, and then we need to divide that by 169.868. And when we do that, we got 4.218599. So a big long number, but we need to round this to just 2 significant figures because that's what we were given to begin with. So we're going to round 1, 2, and this 2 is going to stay a 2 because 1 is not greater than 5. So our answer is going to be 4.2, and then our units are grams of silver chloride. Box that answer in. So, moving on to the next problem. If we have 10 grams of aluminum chloride, and that decomposes into aluminum metal and chlorine gas, how many moles of aluminum are produced? So I went ahead, underlined our given value, unit, and substance, and then I circled what we are looking for. So we need to go ahead and write our balanced chemical equations. We have aluminum chloride decomposing. So aluminum and chlorine. Aluminum is a +3 charge and chlorine is -1. So when we crisscross, we get AlCl3. There's 3 coming down here, 1 coming down there. And then it's decomposing, so that's the only reactant. It's decomposing into aluminum metal, so Al, and chlorine gas. And chlorine, we know, is a diatomic element, so it has to be Cl2. So now we have our skeleton equation. We just need a balance. So I noticed that chlorine is an odd number. So I'm going to go ahead and make this an even number of chlorines by putting a 2 in front of AlCl3. Now I have 6 chlorines, so I can do 2 times 3 to get 6 over there. And I have 2 aluminum, so I'm going to put a 2 in front of the aluminum. So now we have a balanced equation, so let's do some stoichiometry. We have 10.0 grams of AlCl3. And we are trying to get that grams of aluminum chloride to moles of aluminum. So a grams of one thing to moles of something else. Let's look at our charts here. Grams of one thing to moles of something else. It's 1, 2 steps. So we need 2 conversion factors here. 1, 2. Our first conversion factor is going to take grams of AlCl3 and convert it to moles of AlCl3. And our second conversion factor is going to take moles of AlCl3 and convert it to moles of our new substance, so moles of aluminum. To get our mole to mole ratio, we look at our equation. Moles of aluminum, we have 2 moles of aluminum, and moles of AlCl3, we have 2 moles of AlCl3. And to get our gram to mole conversion, we need to calculate the molar mass of AlCl3. So to do that, aluminum's molar mass is 26.982, And then chlorine's molar mass is 35.453. But we have 3 chlorines, so we have to multiply that by 3. 35.453 times 3 plus 26.982. So the total mass of AlCl3 is 133.341 grams per mole. So we're going to put 133.341 grams of aluminum chloride per 1 mole of aluminum chloride. So let's cancel some units here. Grams of aluminum chloride cancels out. Moles of aluminum chloride cancels out. These 2's can cancel out. So all we need to really do in our calculator is do 10 divided by 133.341. So I'm going to do 10 divided by my previous answer. And that gives me 0.07499956. Some more numbers, but we need to round to just 3 significant figures. So this leading zeros are not significant. So 1, 2, 3. This 9 is going to round up to 10 because a 9 rounds it up to 10 because it's greater than 5. So it's going to round up to 10. So we're going to get, and then it's going to add a 5 to here. So this is going to round to 0.0750. As this 9 rounds up to 10, which makes this 50 here. So this has 1, 2, 3 significant digits. This 0 is significant because it's after decimal point and it's not a leading 0. And then our units are moles of aluminum. So you can give your answer like this, or you could put this in scientific notation. Move your decimal point 2 times and make it 7.50 times 10 to the -2 moles of aluminum. So let's think about whether or not this answer is reasonable for a second. Aluminum chloride, we said, has a mass of 133 grams per mole. And so we only had 10 grams to start. So we had well under a mole to start. So if we're thinking about how much aluminum would be produced from that, it's a 2 to 2 ratio. So we should have well under a mole of aluminum being produced from that. So this does make sense. This very small amount of aluminum being produced makes sense if we think about what our reasonable answer would be. So I'm going to box that answer. Next question says, when sulfuric acid reacts with sodium hydroxide, a neutralization reaction occurs producing water and sodium sulfate. If this reaction occurs to completion, how much sulfuric acid in moles is required to make 15 grams of water? So we have our given values, unit, and substance, and then it's asking how much sulfuric acid, and it tells us that it wants it in moles. So first we need to write a balanced chemical equation. So sulfuric acid, there's no hydro prefix, so we know that this must be hydrogen bonded to the polyatomic ion, and since it ends in ic, that means it came from the 8 ion, so it must have been sulfate. Sulfate, which is SO4 with a 2- charge. So when we crisscross this, we get H2 and then SO4. So that's our first reactant, and it's reacting with sodium hydroxide. So Na with a +1 charge, and hydroxide is OH -1. So NaOH. And it's having a neutralization reaction, which is one of our types of double replacement reactions, and it's producing water and sodium sulfate. So water's easy, H2O, but I'm actually going to write this as HOH because I see that we have a hydroxide ion, so I know this will make it easier to balance. So water and sodium sulfate. So we need to recross Na with a +1 charge, and sulfate is SO4 with a 2- charge, so this will be Na2 and then SO4. So now that we have our equation written, we do need to balance our equation. I immediately notice that sodium is out of balance here, so I'm going to fix that by putting a 2 in front of NaOH. And then I noticed that I threw my OHs off. I threw my hydroxides off. I have 2 over here now, and I only have 1 on my product side, so I'm going to put a 2 in front of HOH. So then I have 2 hydrogen atoms and 2 hydroxide atoms. I balanced my hydroxide, but my hydrogen I need to double check. But when I go over to my reactant side, I notice that there are 2 hydrogens as well. So hydrogen's in balance, sulfate's in balance, sodiums are in balance, and hydroxides are in balance. So we are good with a balanced chemical equation. I'm just going to fill in a 1 here and a 1 here. So now we can do some stoichiometry. Our given value, unit, and substance is 15 grams of water, which is H2O or HOH, however you would like to write it. And then since we're doing a gram to mole conversion, we know that that's going to require 2 steps. Grams of one thing to moles of another, 1, 2 steps. 1, 2 steps. Our first conversion factor is going to have grams of water on bottom, and we're going to convert to moles of water. And then our second conversion factor is going to have moles of water on bottom, and we're going to convert to moles of our new thing. So moles of sulfuric acid, of H2SO4. So now we just need to get some values here. Our mole to mole ratio comes from our chemical equation. So there's 1 H2SO4, and there's 2 waters. And then to know our gram to mole conversion, we need our molar mass of water. H2O, we have the mass of hydrogen is 1, but we have 2 of them. So, and then we add 16 because oxygen has a mass of 16. So this is 18 grams per mole for water. 18 grams per 1 mole. So now we can just multiply and divide. So 15 times 1 times 1, that gives me 15 on top. And then divided by 18 times 2 in the denominator. So this gives me 0.41666, a whole bunch of 6's, but I need to round to 2 significant figures. So I'm going to round to 0.41, and the 1's going to round up to a 2 because 6 is greater than 5. 0.42, and our units, here we didn't cancel units. Grams of H2 cancels, moles of H2 cancels. We're left with moles of H2SO4. 2SO4. And then we're going to box that final answer as well. Alright. Just a few more here. So we have lead will react with hydrochloric acid to produce lead, 2 chloride, and hydrogen. How many grams of hydrochloric acid, so that's what we're trying to find, are needed to react completely with 0.87 moles of lead? So we need to write our equation. So lead, Pb, will react with hydrochloric acid. Hydrochloric, that means that it's a hydrogen bonded to just a chlorine atom. So +1, -1, so we get HCl, to produce lead 2 chloride, so Pb with a +2 charge, and chlorine, which has a -1 charge, so PbCl2, and hydrogen. And we know hydrogen is diatomic, so it's going to be H2. So now we need to balance. I'll put my lines this time. I forgot to last time. Chlorine's out of balance, so I'm going to put a 2 here to fix that. That also fixes hydrogen, because there's 2 hydrogens. So now there's 2 over here, and there's 1 lead on each side. So everything else, I could just put a 1 in there. Now let's start with our given value, unit, and substance. So 0.87 moles of Pb. And we're doing a mole to gram conversion. So that's going to require 2 steps. Our first step is going to take moles of lead and take it to moles of our new substance. So hydrochloric acid, HCl. And our second step is going to take moles of HCl and convert it to grams of HCl. So our mole to mole conversion comes from our chemical equation, 2 HCl and 1 Pb. And then our mole to gram conversion is going to come from the molar mass. So our molar mass of HCl, we have hydrogen, which has a mass of 1, plus chlorine, which is 35.453, which gives us 36.453 grams per mole for HCl. So 1 mole of HCl is equal to 36.453 grams of HCl. So now we need to put this in our calculator. We have 0.87 times 2 times 36.453 divided by 1. So we don't need to do that. It's already divided. So we got 63.42822. We need to cancel our units. Moles of lead cancels, moles of HCl cancels, and we're left with grams of HCl. And we need to round this to two significant figures. So 63, the 3 is going to stay down at a 3 because 4 is less than 5. So we have 63 and then grams of HCl. Next up, we have carbon will react with zinc oxide to produce zinc and carbon dioxide. How many particles of carbon dioxide will be produced if 1.45 moles of zinc oxide react completely? So I circled what the problem's asking for and underlined my given value, unit, and substance. So now we need to write our chemical equation. So carbon, C, will react with zinc oxide. Zinc and oxygen. Zinc, remember, is a transition metal that is an exception to that rule that we have to show the charge. So zinc has a +2 charge, oxygen has a -2 charge. So when we crisscross, we're going to get Zn2O2, but then that's going to reduce to just ZnO. And we are producing zinc, Zn, and carbon dioxide, CO2. So now we need to balance. Let's put our lines. So the thing I notice is oxygen's out of balance, so I'm going to put, a 2 in front of zinc oxide. And then I threw zinc out of balance, so I'm going to put a 2 in front of zinc. And now everything looks to be in balance, so I'm going to fill in 1s for everything else. So now let's take that given value, 1.45 moles of zinc oxide, and we are going to multiply by some number of conversion factors. We're going from moles of one thing to particles of another, so that's going to be 2 steps. 1, 2. The first step is going to take moles of ZnO to moles of our new thing, moles of carbon dioxide, CO2. And our second step is going to take moles of CO2 to particles of CO2. Particles. Remember, there's no abbreviation for particles. Just got to write it out, particles of CO2. Our mole to mole ratio comes from the equation. So CO2, there's 1 mole of CO2 and 2 moles of zinc oxide. And then we know that 1 mole is always equal to 6.02 times 10 to the 23rd particles. 6.02 times 10 to the 23rd particles. That's Avogadro's number. So we can cancel moles of ZnO with moles of ZnO, and moles of CO2 also cancels. So we'll be left with particles of CO2. So let's type this into our calculator. We have 1.45 times 6.02 e to the 23rd divided by 2. So we got 4.3645 times 10 to the 23rd. And we need to do correct sig figs. We need 3 significant figures. So 1, 2, 3. This 4 is going to make the 6 stay at a 6. So we're going to write 4.36 times 10 to the 23rd particles of CO, capital O2. There's our final answer for this one.